So we're asked to solve any triangles formed by this given information. So let's first draw that triangle. So here I have an acute looking triangle maybe, where this is angle C. Okay, angle C is 42 degrees. And this side C is always opposites. Okay, so the letters are opposite each other. If this is capital C, then this is side C. And if this is little b, 28 here, that means this is capital B here. Okay, which puts angle A up here and little side A down there. So 22 is the opposite side length from angle 42, and 28 is the adjacent side length. So to figure out how many triangles we can have using the law of sines, rather the ambiguous case, we first calculate the height. And the height is always found by using a right triangle and the sine ratio. You can see, of course, hopefully you can see that this is a right triangle here. We're using the angle 42 that we're given. So 28 is the hypotenuse of this right triangle, and h is the opposite side. So the sine relates the opposite side to the adjacent side, and when you solve that trig for h, you get this. Hopefully that's not a big deal. But putting in our calculator, 28 sines of 42 gives me a height of 18.736. Okay, so the first thing we do is we compare the heights to the opposite side. Okay, and we notice that the opposite side is larger than the height, which means we're going to have triangle or triangles, because if the height was bigger, then you can't have any triangles existing. Then the next thing we check is the relationship between the opposite side and the adjacent side. Okay, this will tell us if there is one triangle or two triangles. So the opposite side is 22, and the adjacent side is 28. We notice that the adjacent side is bigger than the opposite side, which means we can have two triangles that have the same exact information. Okay, so it's important to know because the calculator will only tell you the angles for one of them. So let's do that. This is going to be the triangle that we find. So let's find the measure of angle B using the law of sines ratio. Okay, so that is the sine of angle B over the side B, which is 28. So the sine of B over side B is in proportion to the sine of C, which is 42 degrees, over side C. So the sine of the angle over the side opposite it is equal to the sine of the angle over the side opposite it. So we cross multiply the 22 sines of angle B equals 28 times the sine of 42. Okay, we'll divide both sides by 22. So the sine of B is 28 sines of 42 divided by 22.85. 16207 if you have your calculator handy. And then to get rid of the sine, we always take the inverse. So we inverse sine of B. Okay, that's how we cancel out sine. We don't divide, we don't multiply. We take the inverse function of both sides. Okay, this is what goes in your calculator. So B is the inverse sine of that decimal, which looks like it's 58.4 degrees. Okay, now maybe your teacher wants more decimals, but I only care about one decimal for angles, so 58.4 it is. Okay, now we find angle A. Okay, angle A we use geometry. The three angles of a triangle add up to 180. I mean, you could use the law of, nope, you can't because you don't know side A. So we have to use geometry to find this third angle. So 180 minus the other two angles that we know gives us the measure of angle A. Which is 79.6 degrees. So now we can use the law of sines again to figure out what side length is for A. So A over the sine of angle A, 79.6, is equal to C, which is 22, over the sine of 42. Okay, now I'm writing it differently on purpose. Up here I wrote sine of the angle on top and the side lengths on bottom. And here I'm writing sides on top and sines on bottom. It really doesn't matter which way you do it. Okay, the answers come out to be the same. You still have to cross multiply. So these reciprocals are still equal. As long as you have sides on top and sines on bottom, you're going to be fine. So let's cross multiply 22 sines of 79.6 divided by the sine of 42 gives me an A value of 32.338. Okay, so I like to have my students round to 3 decimal places when they're finding side lengths. 32.338. Okay, so that's the first triangle. Now, let's talk about the second triangle. Okay? So, remember our first triangle looked like this. So this is angle C, and this is angle B, and this is angle A. Okay, this is 42 degrees. This was 28, and this was 22. Okay, so think about AB as being the radius of a circle. Okay, we can continue drawing this circle as it goes around over here until it touches, okay, the triangle again. So this would be the other triangle. It would look something like this. Okay, where this side is also 22. Where this side is still 28, this one hasn't changed. This angle is still 42, it hasn't changed. But now angle B is right there. So we're going to figure out the angle A here from this acute angle. We're going to find angle B here and then side A there. Okay? We do most of it using geometry, actually. This was a 54 degree angle, 58.4. My dyslexia is kicking in, 58.4. And because both of these sides are 22, that means this is an isosceles triangle. So this other angle down here is also 58.4. Okay? Your calculator using the law of sines will only give you this acute angle. It will never give you this angle, your calculator. But because of geometry, we know that these two angles form a linear pair. So the second angle B is found by subtracting the calculator angle B from 180. 180 minus 58.4 means that is a 121.6 degree angle. Okay, so we don't want to use law of sines again, because when we do, we will get 58.4 again, which is not the angle of the second one. Okay, so we use geometry again to figure out that third angle by subtracting the other two from 180. So there's not a lot of pre-calculus when we're figuring out these angles for the second triangle. 180 minus 42 minus 121.6 means that tiny angle is 16.4 degrees. Okay, is angle A up here. Okay, so we find the second angle B by using geometry. We subtract angle, the first one, from 180. Okay, we take those two angles and subtract them from 180 to get A. And now we use the law of sines in order to find out what little side A happens to be. So A, side A over 16.4 is equal to 22 over the sine of 42. Okay, so cross multiply again and divide. 22 times the sine at 16.4, not 164, divided by the sine of 42, means this side is now only 9.283 units long. So what used to be the largest side across from the largest angle is now the smallest side across from the smallest angle. And that's how you find the second triangle of an ambiguous law of sines problem.